In example 4C, we are going to algebraically test the equation 9x squared plus 4y squared is equal to 36 for symmetry. Back in example 2C, we graphed this equation by hand, so let's start there and visually see what type or types of symmetry this graph has. All right, so I'm going to write this down. This is in example 2C. So if we flip back to the top of page 4, here is the graph of this particular equation. So let's talk about the symmetry. For x-axis symmetry, we're going to take our sheet of paper and fold along this red dotted line, the x-axis. Okay, ask yourself, if you fold the sheet of paper this way, would the top part of the graph lie on top of the bottom part? Okay, and the answer is going to be yes. If you folded this way, this would lie on top of this. Okay, so this graph is going to have y-axis symmetry. Okay, it's a little difficult for this particular example to use a particular point and look at the coordinates, because the 4 major points on this oval are all on an axis. Okay, so we're just going to have to visualize this one by folding a sheet of paper. All right, so x-axis is yes. Now we're going to fold the sheet of paper along the y-axis, so along this red dotted line. So you'd be asking yourself, if I folded the sheet of paper this way, would the left side of the piece of paper lie on top of the right side? Okay, and the answer is yes. Okay, so this particular graph also is going to have y-axis symmetry. It is possible to have more than one type of symmetry. Okay, so then lastly, we need to check out origin symmetry. Again, that is the most difficult type to visualize here, and it's even more difficult because we can't really pick a point to maneuver. Okay, so I'm going to go ahead and tell you this particular graph does have origin symmetry, and this is how you can see it. Okay, remember, when you have origin symmetry, you have to do both flips. You have to flip about x and you have to flip about y. So I'm going to take a segment of the graph. Okay, I'm going to take this top part in the first quadrant. Okay, and what I'm going to have to do is imagine flipping this yellow piece about the x-axis and about the y-axis. Where would it end up? Well, it would end up in quadrant 3, and it would correspond to this blue segment. Okay, so if you took the yellow segment and you did the flip, you folded the sheet of paper about the x-axis, and then you folded the sheet of paper again about the y-axis, that yellow part would lie on top of the blue part. Okay, so this particular graph has all 3 types of symmetry. Okay, in that, like I said, it is possible to have more than one type or even all 3 types. Okay, so what we're going to do now is we're going to go back to the equation and we're going to do the test for symmetry, and we should basically get yes, yes, yes. Okay. All right, so what we're going to do here, okay, before we begin, is we want to eliminate exponents. Okay, there's an x squared here and there's a y squared here. So we need to rewrite this equation with the exponents eliminated. Okay, so let me pick a different color here so it kind of stands out. Okay, we're going to rewrite this as, remember, the x is squared here, the y is squared here, the numbers are not. So we're going to rewrite this as 9 times x times x. Okay, that's going to be the 9x squared plus the 4 times y times y. Okay, that's the 4y squared. That's equal to 36. Okay, so that's basically how we want to think about this particular equation when we are testing it for the different types of symmetry. Okay, so I'm going to put this in a box. Going forward, this is how we want to work with this particular equation. Okay, and again, we should expect all 3 types of symmetry to check out here. Okay, all right, so let's get started. Let's start with x-axis symmetry here. Okay, so again, and I know I keep writing this down, but hopefully the repetition helps you. To test for x-axis symmetry any point x, y, what's going to happen is the x coordinate will stay the same. You're going to change the y coordinate, okay? So we need to go to our equation in purple in the box, and we need to replace every y with negative y. Okay, so we're going to get 9 times x plus 4 times negative y times negative y, and that needs to equal 36. Okay, so now what we're going to do is simplify and compare it to the original equation, which I will put in yellow. Okay, all right, so simplifying 9 times x, that's going to be 9x squared. Okay, plus the 4 will remain out front. If you do negative times negative, that's going to be positive. Y times y is y squared. So this is going to be plus 4 times y squared. That's got to equal 36. Okay, that is the original equation. And so, yes, this particular graph will have x-axis symmetry. Okay, all right, so now let's try y-axis symmetry. Okay, so for y-axis symmetry, if you start with a point x, y, this time x will change sign and y will stay put. Okay, all right, so if we go up to the equation in the box where we've broken down the exponents, we're going to replace every instance of x with negative x. So we're going to get 9 times negative x times negative x, okay, plus do nothing to the y, so 4 times y times y. That needs to equal 36. Okay, simplify. The 9 will stay out front. Negative times negative will be positive. X times x will be x squared. So you're going to get 9x squared plus 4y squared is equal to 36. If you compare this particular green equation to the yellow equation, that is the original equation. It checks out. So this particular equation, its graph is going to have y-axis symmetry as well. Okay, finally, if we look at origin symmetry, okay, we know that if we start with a point, we're going to have to change the sign of both coordinates. Okay, so go to the equation in the box. Okay, everywhere you see an x, you're going to replace it with negative x, and everywhere you see a y, you're going to replace it with negative y. Okay, so we will get 9 times negative x times negative x plus 4 times negative y times negative y. Okay, that needs to equal 36. All right, we need to simplify and see if we get the original equation back. Okay, so this is going to simplify to be 9x squared plus 4 times y squared is equal to 36. If you compare this simplified equation in purple to the original in yellow, they are the exact same thing. Okay, and so we can conclude, yes, this particular graph also has origin symmetry. Okay, so we have observed from the graph and we have confirmed algebraically that the graph of 9x squared plus 4y squared equals 36 has all 3 types of symmetry.